Okay, I give you some time. So when you cannot join from your laptop or you are outside, try from your phone, okay? At least you don't miss the class. Okay, so what's today class? It's supposed to be practical, but because we are away, so there's no practical and not very important. So today we start with endocrine pancreas, okay? And we finish, I think, on Tuesday our class. Okay, Akil, are you ready? Akil?
Yes, Ada.
So we can start now.
Yes, you can start now.
Okay, all right. So endocrine pancreas, we already covered exocrine pancreas during GIT system. So pancreas itself, we have exocrine and endocrine. Endocrine part, which also we call it islets of Langerhans. So it's divided into group of cells. So we have 4 group of cells: beta cells, alpha, delta, and F cells. Okay, Shahira is trying to join. So we have only Nakib, I guess. Okay, so those will secrete insulin, glucagon, somatostatin, and pancreatic polypeptide. So I think you know
Doctor,
the histology. Yes.
Akil said he can't because he has appointment with officer
Uh,
from the
okay, no problem. Thank you, Akil, for help. All
okay.
right. So I think histology and biochemistry already cover. So today we try to cover as much as we can from the physiology part. So it's this part of pancreas is dealing mainly, not only, mainly with glucose. So we need to know what makes our blood glucose high or what makes it low. Let me start with Ahmed. Ahmed, what makes your blood glucose high?
Physiologically or pathologically?
No, we are talking about
Yeah, okay.
normal. Normal. So what do you think now? Now, is your blood glucose high?
For example, if you are eating sweets or
Yes.
sugary
So
foods.
we can say food in general. Okay, so but not all food will increase your blood glucose.
Yeah.
So when you eat something, so you expect that you got some glucose. So when you eat after eating a meal, but definitely it depends on type of meal. So what type of meal can increase your glucose? Let's ask Arafat.
Maybe rice.
Rice, yes, rice. Rice under which category? Is it protein, carbohydrate, lipid?
Carbohydrate.
So carb, and like Ahmed said, another example, sweets like maybe candies, maybe cake, chocolate. So all of those things definitely increasing our blood glucose, but the increase, this kind of increase that we need. So why you need glucose? Why you need glucose, Matira? Matira, is it important to have glucose in your blood?
Yes.
Yeah, of course. What do you need to do with glucose?
For the cell metabolism.
Okay, so you are going to send into all body cells. So what body cells will use glucose for?
Uh, mm,
Azul? Thank you, Matira. Azul?
I think it is convert for our body for having the energy.
Yes, energy, very good. So for energy, okay, or as Matira said, for metabolism, so we need energy. What's the energy for Kai?
What's the energy for?
Why you need energy?
For
You don't need energy, Kai. You won't sleep. What do you use energy for?
Working.
Huh? Nothing. You don't need energy. You don't need. Okay. Anis, do you need any energy or not? So Kai can deliver her energy. What do you use energy for? Hmm? Yeah, for all our activities, such as like now you said breathing. To breathe, you need energy. What else you need energy for?
Movement.
Just to breathe. That's it. Yes, to walk, to move. Why you need to
Study.
walk?
Pintu.
Hmm?
What data?
Why you need to walk, Anis? Yes, walk. Berjalan kaki.
To release tension. Release stress.
Okay, release stress. Okay, stress of study. What else? If
Reduce
you don't
fat.
study, huh? If you don't study, what humans need? Why humans need to move? Have to move
To
To survive.
to
to
work.
survive. Yes, to survive. If you don't move, you cannot survive. You need to have your food. You need to. You have to move. Okay. Okay, so glucose, one of the sources of glucose, or we can say we increase blood glucose for our energy, and the main source is food. The main source is food. Okay, okay. So now you can still move, isn't it? You can breathe. You can do all of the normal activities while you are fasting. Means you are not eating except siva. So you are not eating, but you still have glucose or not? Do you? So you are still alive, isn't it? You're still breathing. So
Yes.
that's the most simple thing. So to breathe, you need to use the muscles, respiratory muscles. All of those muscles need to use glucose, isn't it? So to breathe, at least you need. So that's very good example. So you need glucose. Now you don't have the main source of glucose, which is food. Hazila, can you give me one example? If you cannot eat and still you can got glucose. I help you, huh? You are fasting. If you are fasting, do you have glucose in your blood or not?
Yes.
Yes. So where's the source? Do you eat now? No.
No.
Expect that you are not eating, okay? So you are not eating. Where is the glucose comes from?
We have storage in the liver.
Where?
Liver.
Yes, very good. So how we got the glucose from the liver? Okay, let me try with Akil Misra. Okay, are you agree with Hazila? If you are when you are fasting, or even between the meals, or while you are sleeping, so you still got some glucose. Or if you are running, you need more than usual glucose, or you are doing any extra activity, so you don't have to eat 24 hours non-stop. So you still got glucose from the liver, yes or no? What is
Yes,
wrong?
glycogen.
Yeah, glycogen, okay. So liver already has the starch, which is
Yes.
glycogen. So is glycogen glucose?
No, glycogen
To
is
be convert.
Convert, yes,
glucose.
into
Yes.
glucose. Very good,
Yes.
thank you. So the liver can be another source of glucose. What else?
Fat, protein,
How? What we call it?
gluconeogenesis.
Yes, gluconeogenesis. So also it's mainly by the liver. So the liver can convert non-carbohydrate sources into glucose. Okay. So the glucose, the main source of glucose from our food, mainly from carbohydrate. Okay, mainly. Okay. So from here we can just. Okay, so we have, we can say glucose mainly from food. That's number one. Number two, from liver. From liver, two ways. We have breakdown of glycogen. That's one way. Another way, we can produce new glucose from non-carbohydrate sources. Okay, so that's two ways. Okay, so factors, we can say factors or increasing our blood glucose, increasing the normal one. Okay, we are not speaking about pathological. Normally, we have glucose, number one, from food, our food. So we already know the process from carbohydrate. We have digestion and absorption of carbohydrate. So we got glucose and other sources also for energy. From liver, mainly converting glycogen into glucose. Number two, from the liver also producing new glucose from non-carbohydrate sources. Okay. So what decrease glucose? So why glucose is going up? So you are eating, you are having meal, you reach what you need from glucose. So what makes glucose going higher normally? What would make glucose higher? Layani, can you try?
What makes glucose higher? Decrease uptake of glucose from the cell.
In the blood, in the blood.
Glucose unable to enter the cell. Decrease uptake.
That's something abnormal, isn't it? So what normally can increase your blood glucose?
Thyroid hormone.
Okay, who can try?
Maybe stress.
Something else? Yeah, your answer is all correct, but I need something else. Aynan, can you try?
Is it because when the glucose level is low, then the body needs to increase glucose because of negative feedback?
Okay, good try. It's correct, but I need another thing. Shahira, are you still here?
Maybe because we need energy.
I cannot hear you, Shahira.
Maybe because we need energy.
What makes blood glucose going higher normally? High. Ayun?
The hormone.
Because of
Exercise.
Exercise.
Exercise, you are using glucose, isn't it? You are using glucose. Who wants to try? Who I didn't ask today? Aisha?
Gluconeogenesis.
Okay, something else on it?
Doctor, how about dehydration?
No.
Glycolysis.
We need something normal, very normal, to increase blood glucose. So if you find somebody with high blood glucose, you have to ask a question. Or to avoid, you have to do something.
Eating,
yes. Yes, good. Who said eating?
as you know.
Yes. So if you eat too much, a lot, so of course, definitely your blood glucose will get higher. Okay. So let's say now it's 7:20 p.m. So if you eat non-stop for 2 hours, what will happen to your blood glucose?
Increase,
isn't it? Okay, increase, but it's not pathological reason. So what your body can do, how your body can decrease it? Insulin. Okay. What insulin? How insulin? Is insulin eating or break down glucose?
convert glucose.
Okay, how insulin can minimize the blood glucose? So you ate too much, you have a lot of glucose in your blood, so you will get insulin. Correct. What insulin is doing to the glucose?
Promote glucose uptake by cells and muscles.
Yes, yes. So glucose will be uptaken by almost all body cells, so it will be decrease. So if you are eating too much and you still, even with the help of insulin, you still have glucose, what would happen? Siva, can you speak or not? Siva, can you share?
Doctor, no, doctor.
You can share yes or no. I cannot hear you. Okay. If you eat too much, so insulin will minimize blood glucose. Okay, insulin still needs support. Here, you look at the slide. Still you have extra glucose. What will you do with this extra glucose? So you distribute for all body cells, but still you have extra glucose. What will you do with this extra glucose?
Convert to glycogen. Convert into glycogen.
Yes, who said storage? Yes, correct. So the extra you will store or will be delivered into the liver. So the liver will convert it into
Glycogen.
glycogen. Any other organ we can deliver glucose to? Not for use, for storage.
Muscles?
Muscles, yes, very good, excellent. So we can deliver into the liver, mainly into the liver, and also we can deliver into the muscles. Very good, very good. So we can, if we have, so those factors means decrease blood glucose. So we increase blood glucose by eating, we increase blood glucose by having glucose from the liver, convert glycogen into glucose, producing new glucose. So all of those increase. Decrease, it's I want to change the slide. Okay, decrease, so we can send glucose into body cells. So those body cells can use it for energy and also can store like in liver and muscle. Okay, I need 1 point. I don't know if you saw it or not. If you saw it, don't mention, okay? Only if you know it already. Okay. We have a lot of glucose. We send to the body cells. Everybody cell already has enough glucose. You still have more. You storage the extra in the liver and muscle. Still you have more. What will you do with this more?
Store in the tissue.
Sorry?
In the adipose tissue.
Okay, still you have more. So we're done with the using glucose by cells and you're done with storage. Whatever the tissue, we already store and already all our storage rooms full. We still have glucose.
Excrete.
Excrete from where to where?
Urine.
Excretion, you mean?
Excretion, yes.
Excretion in the urine. Very good, excellent. So you can see you have glucose, you have normal amount, so you can deliver it to the cells. You have more than that. All body cells satisfied, you store, you still have more, you can excrete. In the urine, we already mentioned during renal system, it should be 0, isn't it? So if we have glucose in the urine, means this person already ate too much, or after meals also we can find. So that's why when we check blood glucose to if we suspect somebody diabetic, so it has to be fasting, so to avoid the negative results. Okay, so factors decrease blood glucose. So imagine you have a lot of blood glucose, so you're starting to decrease it, using by cells store and excretion. So excretion in the urine only in case if you have too much glucose. So the glucose will appear in the urine or after meals. Okay, but doesn't mean it's diabetic or abnormal. So we need to double check. So we need to avoid other factors. Okay, we move on.
Yes, doctor.
Yes,
Okay.
doctor.
So when you eat, you got glucose. So we need to know the mechanism of secretion of insulin. So you can see that insulin secreted if you have high blood glucose. So increase high doesn't mean the abnormal high. So once you have glucose in your blood, increase by the time, so it's like after meals. So beta cells in the pancreas will start secreting insulin, and we have mechanism. How much time? We still have
15.
Less than 15 minutes. Okay, I think this one we do it next class. Okay. So today we mention what insulin is doing for carbohydrate, fat, and protein. Okay, effect of insulin on carbohydrate. On carbohydrate, we already know one of the main effect, or the most important effect, facilitates glucose transport into most or almost all body cells. Okay, so insulin. So we have body cells. So insulin facilitates entering of glucose into all body cells. Okay, so that's the main function. Okay, the second function. Okay, so one of you already mentioned adipose tissue. So glucose will be used by or uptaken by also adipose tissue. Okay, adipose tissue. So then glucose itself will be used. It's like ingredient for adipose tissue to produce fatty acid and glycerol. Fatty acid and glycerol. Okay. Okay, so means once we have fatty acid and glycerol, means we already got function number 2, which is promote or enhance or facilitate or stimulate producing of triglycerides. Okay, from glucose and fatty acids. From fatty acids, it's of course we know, but from glucose, from function number 2, that we know that adipose tissue use glucose to produce fatty acid and glycerol. So those fatty acids and glycerol will be used in producing of triglycerides. So we can say indirectly, glucose used for triglyceride production. That's why if you eat a lot of cakes or chocolates, so you gain weight. So your fat will be increased more and more. So, but you are eating glucose, but the fat increase because extra glucose will be converted into fat like that. So any extra glucose we use for the cells, we store in liver, in the muscles, in form of glycogen, excretion in the urine. But if you still have more, so insulin will try to figure out more effects on glucose to be disappear from the blood. So one of the things that will convert into fat, glucose converts into fat. How? Insulin facilitates uptake of glucose from blood into adipose tissue, Okay, so here you have, this is adipose tissue and this is blood. Okay, blood. So this is adipose tissue or adipose tissue. Okay, adipose tissue. So what insulin is doing? Insulin will facilitate uptaking of glucose by adipose tissue. So within adipose tissue, glucose will be converted into fatty acids, and glycerol. Glycerol. So definitely glycerol and fatty acids within this adipose tissue will be converted into triglyceride fat. So you can see by the end glucose, extra glucose converted into fat. Why? Because of insulin. And why we convert it into fat? Because we have extra glucose, too much glucose. So anybody, if we eat in balance amount, okay, so this won't happen. This happen only if we eat a lot, if we eat extra chocolate or cakes or any kind of sweets, or even any normal carbohydrates, bread or rice or pasta. So the extra will be converted by the end into fat. And insulin itself, the bad thing that insulin inhibit breakdown of so we have only one way. We don't have insulin doesn't do this. It will inhibit convert of triglyceride into glucose, or breakdown, or even breakdown of triglyceride into fatty acids, free fatty acids, and glycerol. Okay, inhibit. So of course, if we have fatty acids, means we can got glucose, because insulin trying to minimize glucose. So that's why insulin inhibit lipolysis. Why? Because you can see the end result is glucose. So if we break down triglyceride, means we will got fatty acids. So means we can use those fatty acids to produce glucose, gluconeogenesis. So insulin, this is not function of insulin. Insulin trying to minimize glucose. So that's why it has to inhibit lipolysis. So this is the effect on fat. Okay. So uptaking of adipose tissue. So it's like story. Function 1, 2, 3, 4, like story. Insulin facilitates adipose cells to take glucose. So once taking glucose, convert this glucose into fatty acids and glycerol. So after that, fatty acid and glycerol will be converted into triglyceride. And we promote, as insulin, promote triglyceride production. So it will inhibit breakdown of triglyceride, because if we break down of triglyceride, we are going opposite. We got glucose again. So that's not the function of insulin. Okay. So by the end here, you can see we decrease glucose in the blood. Okay. By insulin working on fats. Okay. Carbohydrate, I think we already know. We can go through carbohydrate. On carbohydrate, facilitate glucose transport by all body cells, stimulate glycogenesis, means convert of glucose into glycogen. So remember that insulin, you have to remember that insulin will try to the best to decrease glucose in blood. Okay. Try to decrease glucose in blood. That's the main function of insulin. So if we say what's the function of insulin, what insulin is doing on carbohydrates, so the main thing has to decrease glucose. So uptaking of all glucose. Why we say glucose? Because the end degradation product of carbohydrate, the main thing is glucose. Okay. Digestion of carbohydrate mainly will go to glucose by the end. So all glucose will be taken by the cells. That's number one. Number 2 will stimulate stimulate glycogenesis, means convert of glucose into glycogen. Okay, so this number 2 means convert of glucose into glycogen. Number 2, convert of glucose into glycogen, means by this way also we decrease glucose in the blood. Number 1, taken by the cell, so we decrease glucose in the blood. Number 2, glucose convert into glycogen, means we decrease more glucose from the blood. Number 3, we have to inhibit glycogenolysis, means we have to inhibit convert of glycogen into glucose. All of this biochemistry. Okay, inhibit convert of glycogen into glucose, means we don't increase blood glucose. By this way, we don't increase. Okay. Okay. Number 4, inhibit gluconeogenesis, means inhibit producing of more glucose from non-carbohydrate sources. Okay, so you can see all those steps, all of them working together to decrease blood glucose by insulin. Okay, 1, 2, 3, 4. So from here, can you guess what's the effect on protein? So effect of insulin on protein. What do you think?
Stimulate anabolic
process. So on protein. So what's our base? The most important that insulin has to decrease blood glucose. So what's the effect of insulin? Effect of insulin on protein.
Promote anabolic process.
Okay, if we talk about protein, we will talk about amino acids, isn't it?
Yes.
Amino acids in the blood. Okay, amino acids in the blood. So what do you think? Is insulin facilitate uptaking of amino acids by blood, by cells, body cells? Or, okay, so we have protein, and we have amino acids. Okay, so which way are we? Is the insulin working this way or insulin working this way?
To the left.
Yes. Amino acid to protein.
Protein.
Okay. Then what will happen? If we convert, if insulin promotes uptaking of amino acids by the cells, so means those cells will use amino acids to produce protein. Okay. So what else?
Reduce. No.
Yes. So we have to inhibit maybe something else, or we So they think you need to inhibit protein degeneration, breakdown of protein or not?
Yes.
Okay. How about amino acids? If we have some amino acids, what would happen to these amino acids? If we have amino acids, so our body can use it to produce glucose. Isn't it? So
yes.
What insulin doing here?
Inhibit. Inhibit
the gluconeogenesis. So, are you agree or not?
Yes.
Yes.
Agree, doctor.
We can think that amino acids will convert into protein. Then we see, is it correct or not? Also, we are thinking that protein. So this one, there is stimulation here. This one inhibit of convert of protein or degradation of protein into amino acids. So this one we have to inhibit. Also, using of amino acids to produce new glucose.